So we're back at this with two-dimensional arrays, and what I want to show you in this video is an alternate way of handling two-dimensional arrays. So what we're going to do is we're going to still have it two-dimensional array like this. The one major change that I want to make to this version of the program is showing you that we don't need this athlete count. So we had created a completely separate list, and that was designed to just keep a count of how many athletes we had in each of our individual lists. So for this one here, the athlete count in position 0 would be 0 because there are no elements. In position 4, it would be 1. And in position 23, it would be 2 because we had 2 elements that we added. But that's a bunch of extra data that maybe we can get around using. And here's how we're going to do this. So let's go down to where we are inserting the new value. So I want to wipe out kind of this method. Well, and you know what? I'm going to need this eventually. So I'm just going to maybe put that as a little comment down here just so I don't have to copy and paste that again, because you know one of the possibilities will be out of space. Okay, so let's review this, inserting the athlete into the list, and do it in a way such that we don't actually need a count already of how many athletes are in the list. We're just going to look for a blank space. So what we need to do for this then is we need to check for a blank space. So we're going to traverse the individual list we're going to put our athlete into and see what we're looking at. So I gets the value 0 while I is less than athletes. Now, which list of athletes are we going to look at? It'll be based on what number the user has just entered. Dot length. They'll all be 10 for this example, but I want to keep it with that notation here. So this is, I'll put a comment here. This is going to traverse names. So we already know which list of names that we are going to use because they've already put in the number. We know which list we're putting it in. So what we need to do is we need to find an empty element. So if if we find an empty space, if athletes, this is which list we're putting it in. This is the element of that list that we want to check. And let's check to see if it's null. If it is, then what we're going to do is athletes new num. So which, this is again for which list, which element, it'll just become the new name. And then what we want to do is once we've found where it's going to go into the list, I want to break out of this. Now, our alternate condition is maybe the list is full. So how do we determine that there's actually something in each of those lists? So this will be an else if. So otherwise, if I is equal to athletes new num, dot length minus 1. So we know that we're on the last iteration. Then what we're going to do is we're going to put this message that I put down here, that it is out of space. Now, it might be your instinct here to also check to see that, yes, we're on the last space, and also it's not null. But the thing is, because it's an if-else ladder, we just passed by this. We know that it's not null, because if it was null, then we would have put the athlete's name here and broken out of the loop. So you don't have to put that as a case here. So this is a way that you can program the exact same thing that we just did. So just to prove it, I'm going to run the program. I'll spell athletes better. Where did I put that? Athletes. There we go. There we go. So I'm going to put the same list for Uwe Krupp, 23, LeBron James, and 23, Michael Jordan. And then 100 to quit. So it still stores them correctly. We can still access it. It's just we don't need an exterior list if we're a little bit craftier about how we're inserting them into our individual lists.